So if you've had a coffee or 2 or 3 today, then you need to pay attention because your favorite drink is under threat. I'm going to tell you a story. It's an unexpected story. I'm going to talk to you about plants, but I'm a physicist, and I may look nice, but I poke tiny plants with needles all day long. I'm not the villain here, though. The real villain of this story is a disease-causing germ. Now, the plants on this table look pretty carefree, but germs will wreak havoc on their lives. Germs infect plants and cause disease, which you may recognize as spots, wilting, or scabs. Diseases can also ruin food crops, and in fact, up to 40% of crops worldwide are lost to disease. Now, imagine this is enough coffee for everyone in the world. If we were to lose nearly half of this to disease, then a lot of you are going to miss out. Now, you might be able to live without your morning coffee, but this is life and death for the over 1 billion people who suffer from malnutrition. Finding a way to keep plants healthy is important, but I never thought I'd be the one to work on it. I did a degree in physics, studying how forces control the world around us, from the motion of stars through the sky to the path of a ball through the air. It turns out, though, a lot of these equations can also explain things in biology too. Let me show you how. This balloon is a plant cell. Plants become infected by disease when a germ latches onto the side of a cell and then stabs through to wreak havoc. Tragic. Luckily, plants do have a way of defending themselves, and it's called the cell wall. The cell wall is a rigid structure around the outside of a cell. It's like a castle and can detect an attack and send knights to fight off a germ by physically strengthening the wall at that site. In the lab, I mimic germs using tiny needles about 1/10 the width of human hair. I poke plants and see how they respond. I'm interested in the physical factors like the force exerted by the germ, how much pressure is required to trigger the knights to mount a defense, and how long it takes them to fight back. I bully the plants, but it's for their own good. I'm the unlikely hero, creating an army of knights in shining armor who will protect plants, including the coffee bean, from disease. So I hope anyone who has had a cup of it to drink today can appreciate this goal. Thank you.
I don't think anyone needs a coffee after that demonstration. Thank you, Toby.
I'm curious, if you can increase that defensive mechanism and make it stronger, are there negative implications to that?
I guess in terms of biology, everything you do costs energy. So if a plant can have a really strong cell wall, then the energy and I guess resources to build that are coming from somewhere else. So it's going to be a fine balance between defense and other important things you need to do inside the cells.
As a physicist, how were you welcomed by the botanists? Did they think you were a strange interloper, or did you adapt very well, easily?
I am a little bit like a fish out of water, talking to a lot of biologists about this issue because it is inherently a biological problem, plant disease. But I think I've been well received because I'm coming at it from a new perspective, from this physics side. And I think that sort of collaboration is what we need on something that is such a big and important problem.
Thank you. Yes.
Thank you.